So Pipistrel started as a family-owned business 35 years ago, approximately, catering the recreational segment. We were also one of the first exhibitors at AERO. My first time at AERO was 1994. I was about this, much skinnier, but interested in aircraft and flying as not even a high school student yet. As of 2 years ago, the company was acquired. There was no family legacy available from the founder. And today we are amidst the legendary brands of Cessna, Beechcraft, Macaulay, Bell, under the umbrella of Textron Corporation. The company today is roughly 350 employees. So we're able to produce one aircraft every working day. We operate on 5 different locations. We opened a new one last year, dedicated to research and development topics, mostly hydrogen-related ones, actually. And we are adding capacity this year as well, in particular when it comes to prototyping flight and production as well. So 10 different aircraft models. We operate in 102 countries as of last week. And we flew on all continents with our customers. And we still continue to carry the title of the only aircraft lighter than 1 ton to go to Antarctica and come back, which is significant. So if you look at our lineup today, roughly speaking, there's 4 pillars. The well-known general aviation range with the 2- and 4-seaters, which includes the Velis Electro, today mostly used for pilot training, initial pilot training. We have our dedicated optimized light sport range, mostly for the US market, the gliders and the unpiloted aircraft. And you may have noticed that more and more electro words are finding themselves in the portfolio itself. And for the future, this will very much be the trend as well. Back in 2018, we decided intentionally that no new product development will take place if it's not at least hybrid electric or zero emissions from the get-go. So our journey is very, very clear. So when you look at the Textron context, the whole panoramic view of general aviation, the products are quite well known, right? They start with 4-seater piston offerings, also used in advanced pilot training, and they go all the way up to large business jets capable of crossing the Atlantic. And we fit perfectly on the bottom end. So today, Pipistrel adds the capability so that Textron is able to deliver products that range from gliders to large business jets. If you want to buy some, stop by the booth. So what do we do? Now we're jumping into technology. So this is a full disclosure. So competitors, please feel free to take photos of this slide. This is what we are currently working on today, which is not directly linked to products yet. But we absolutely anticipate every single technology bit from megawatt class propulsion, hydrogen technology, when it comes to integration, batteries. We're currently building modules from Gen 3B, Gen 4, including solid state, Gen 5. We're busy with autonomy and airspace management for large drones, and we are increasingly interested in multifunctional structures. So how do we better package up things we absolutely necessarily need to have on board aircraft? And an example like this is structural batteries. I'm happy to announce that within 2 years, we will fly a wingtip, which actually is the battery. Mind blown? I'm pretty excited about that. So from the past perspective, our journey of electric flight is actually quite complicated, but one can dissect it into a few different streams. Right? The upper one discusses the aircraft and propulsion system interactions and integrations. And you might see quite aerodynamic glider-looking aircraft that are representing this trend, and that's not a coincidence. The red trajectory, for those who see it, I would call it the embodiment of practical electric flight. This is where Velis Electro also belongs to. It didn't start with the Velis Electro, it started quite a while back. But this is where we try to cater practicalities to pilots that don't need to be engineers, that don't need to have special knowledge about electric flight. They just want to enjoy flying. So we take care about things such as charging and intuitive interfaces, and obviously safety and certification. And then we have 3 exploratory pathways. One having to do with propulsion architectures, that's the green. The second one with the different ways how we can fly, meaning move cargo and people around. And the third one is really trying to advance our technologies by finding ourselves in adjacent industries. Yeah, so, for example, we have catered our systems to other aviation makers, not only to ourselves in the past, and we continue to do so where this is of interest. But we start back in 2007. Do you remember a meaningful event from 2007? Probably not. The hit summer song was Macarena. That's how far back that was. And actually 2007 is as far away from today as 2041. And people make big promises for 2030, 35, 40, and time is running. But also, this moment in time, so today, 2024, is about halfway in length to what took humanity to transition from horses to cars. Yeah. So is the transition fast or slow? I give it to you to think about, but that's where we stand, right? Not every technology migration is as quick as people might desire or as it seems, but this is reality. So for us, 2007, we flew electrified gliders, some 50 horsepower for approximately 20 minutes. We took industrial electric motors from industrial washing machines, put together batteries with sticky tape, and I'm not kidding. These were early times. Invented user interfaces and made power controllers from existing DJ digital signal processors. So the audio industry. But it worked, it took on, it became a product, not in 2007, but a few years later, and it actually enabled people to fly self-launching gliders from where previously they could not. Because we also offered solar trailers, so trailers for the gliders that had solar panels and dedicated batteries. So essentially, when you landed, your gear was cool from solar energy. And then you could also recharge your aircraft for the next flight the day thereafter. And people started to fly our gliders in very remote areas, in the middle of Namibia or Argentina, and some very cool stories emerged because they were not connected to the availability of fuel or the infrastructure associated with that. You could literally fly wherever, whenever, with an asterisk, there had to be sunshine. 2011, we took part in a NASA race, put two aircraft like this together, because we didn't have anything else, slammed on a massive battery, which was at that time, and possibly still today, the largest battery that ever flew, about half a ton, and it was triple redundant. This aircraft flew for 2.5 hours back in 2011. It wasn't very practical. Ideal aircraft for divorced couples. One cabin on the left, one cabin on the right. It could technically carry 4 people. Efficiency-wise, and why we think traveling by air makes sense. So this aircraft is an equivalent of 100 passenger miles per gallon per person. So imagine that you have a car, for those who are used to American units, that does 100 miles per gallon. In European terms, 2 liters of fuel equivalent per 100 kilometers at 180 kilometers an hour.
Not bad.
Not bad. So that was the story. And we then started to think about, hey, with the exploration of redundancy and bigger batteries, can we actually make an aircraft that benefits from flying electrically all the time? Not as gliders do, for the takeoff and the climb, and then people glide. And the proof of concept was called What's Up, and it quickly transitioned into Alpha Electro that actually sold to customers. 80 horsepower equivalent, about 45 minutes of fuel. This aircraft took the very limits of what the light sport class permitted globally. Typical markets were Australia, New Zealand, also adjacent in Europe, and some in the US under the experimental ticket. We also started to develop in the, let's say, quite classic aviation way, faster, stronger, mightier. So Pipistrel was the supplier to the Acrobatic Extra project, courtesy of Siemens e-aircraft and Extra Flugzeugbau here in Germany. This was the battery. Perhaps not trivial. The reason why we were interested in this battery was actually the fact that the acrobatic loads, and this is how the battery looked like when it was installed in the aircraft, pretty much matched crash loads that a typical training aircraft has to survive. 9 Gs for acrobatics and a factor of 2 for safety, 18 Gs. That's kind of exactly your crash load. And with this battery also we learned how to effectively crash batteries and not hurt people that are nearby. And this then transitioned into batteries of our own. These were from the early WhatsApp prototypes. They're quite small batteries. These chocolate bars are called pouch cells. That's how they went into the box. And that was the concept back then. This was 2015. The battery was arranged in 6 enclosures. Looks comfortable to hold, but it was 25 kilos each. And we did that because at that time, there was no visibility about fast charging. So this aircraft had to spend between 4 and 5 hours connected to the cable, charging, so that it could fly for about 45 minutes, which wasn't great, right? So we looked into what it would take to actually turn around the aircraft quicker. Reality was that people did not appreciate this fitness exercise. They stopped manipulating batteries, and we pushed into high gear towards high-speed charging that we enjoy today. We can spend a bit more time on that, but these were the early times. Concurrently, Project Hipster began because of our excellent relation with Siemens e-Aircraft back then. That was a project to develop what was believed to be, at that time, the first certifiable hybrid, series hybrid powertrain for aviation. When we say certifiable, meaning that the components actually anticipated failure modes that aviation needs. So they wouldn't quit at the sign of first trouble, there would be some redundancies, some failovers, and enough information passed to the pilot for him or her to even know what the machine is doing. So Siemens developed components from scratch. Pipistrel contributed the integration, the cooling, the battery, and there came this ground test bed, which quite successfully tested all of the operational modes. So for those who will be looking at the images carefully, you will see that some of them show the complete aircraft, and we showed this also at AERO in 2015. And some show aircraft that is a bit less complete. By the way, this engine at the front is the foundation of what Rolls-Royce is still pitching as the 260 kilowatt platform. Back then, almost 10 years ago. So things take time. So that was our test cell, i.e. the parking lot in front of the company. And you see the fire protection involved. Not enough knowledge was available, so we just didn't know better. And today we handle things differently. So here's the first image with the aeroplane's tail missing. That was out of a protest, because the lawyers came in and said, you will not fly something that's not proven. So we made sure we will not fly. That's the reason. These are the batteries, lots of spaghetti wires. These were air-cooled. And one of the learnings was that batteries not only need help in terms of range extenders or different hybridization options, they are also not as trivial for cooling and thermal conditioning than one might think, especially if they are placed into the wing. So this is the first known idea of placing batteries into wings, which are critical structures, right? So safety needs to be taken care of even more carefully. So that was Hipster. If we looked at what people thought about electric flight back in 2015, one of the more famous slides, which was circulated here, I'm showing, and that was at a symposium in Stuttgart. And Professor Martin Hepperle, who's a well-known propeller doctor and also an integration scientist for alternative flight, actually showcased this to paint a picture where batteries actually find themselves comparing to other solutions that power aviation. And you see aviation fuel far off to the right. That's where you want to be in every chart, you know, like high and to the right. And the batteries are the blue bubble somewhere in the middle. And the blueness is actually the occupiable zone together with the anticipated battery advancements, right? The physical frontier of what batteries could do. And yes, it's a factor of 60, because the axes are actually logarithmic here. It's not linear. 60 times worse than the density of fuel and about 20 times less dense. So why would we spend time continuing pursuing battery-powered flight? That was kind of what was the public image of e-flight back then. I actually took the courtesy of adding one dot on this chart in Slovenian. It's called smetana. Don't remember the word, it's silly. It's heavy cream, condensed milk. It's better than batteries. So biofuel very much stands a chance. Batteries will always need help. So hydrogen is an interesting candidate for helping batteries, for sure. We also conducted a bit of let's say, human factor research. We took surveys with universities, with companies, with people who showed interest in electric flight. And what we learned is that, you know, the whole understanding found itself about here. So we basically painted the result on a like-dislike axis. Facebook was very actual back then. And the horizontal axis was actually about understanding, right? And we had a lot to do. And what those surveys actually told us is that if we are going to break through with electric flight, and I'm still coming to why we were pursuing that, why we still do, we had to start educating big time. And we had to start with decision makers, policy makers, universities who bring up new talent, new engineers, new people interested in this, final users, but also the authorities. So that's when we decided that our next product is going to be type certified. That was 2017. We successfully flew the WhatsApp Alpha Electros, were shipping to customers, and we thought we understand engines enough to certify them first. You start with the propulsion and then you add the aeroplane, you know, the class. It doesn't work like that, but that's what we thought. Out came the Velis Electro, 2020, receiving a type certificate, which basically put electric flight onto the map of aviation, matching it with safety and capability to any other kind of aviation. It became standard. It emerged out of this experimentation bubble. So Velis Electro for us as the company always was a pathfinder, but it needed to be upgradable. It's an aircraft that started with the ability to handle a typical student's brain. About 45 minutes plus a bit of extra. This is what the lesson takes. And we already had the technology for fast charging, so you don't anymore replace batteries between flights on this product. So one of the untold aviation design secrets is that you basically design aircraft in the smaller general aviation segment according to human capability. Trainers about the cognitive capability, the window of concentration, about 1 hour, right, for every student. Recreational flight about the human bladder's capacity, about 3 hours. And you don't actually need much more than that. The rest is air transportation. But Velis, there's now 100 of them flying with customers, not only in Europe, happily accumulating hours, and they are already flying with the generation 2 of battery. So these aircraft, only after 2 years since the first certification, started to enjoy the first upgrade, and more are coming. So if you've noticed, generation 3, 4, and 5 batteries, we very much anticipate that this will find themselves into this same product when the time is right. So electric flight caters to users something that conventional powered aircraft just do not. How many conventionally powered aircraft become better over time? Well, maybe you slam a new cockpit and it becomes sexier from the inside, but they don't fly faster, longer, or cheaper. These actually do. So for us, electric flight is not only about catering to the environment and flying clean and with less noise, it's actually opening up aviation to people that did not have the opportunity to fly before, to keep improving and to offer entirely new ways of how we fly. And it started in commercial terms with pilot training, but we are not done yet. So while we were certifying the Velis Electro, we were also busy on the technology development front. Project Mahepa was essentially the mindset successor of Hipster. So Hipster stayed on the ground. We obviously wanted to fly. And the topic of hydrogen started to emerge about then with a bit more traction. 2017, together with DLR, Stuttgart, a few universities, we actually decided to set up the research project as a bit of a competition, head-to-head. So it's not coincidental that these infographics are drawn this way. An aircraft using a gasoline-powered hybrid range extender system and an aircraft that's entirely zero emission. You see that they are different in shape because there is limitations in every part of the powertrain. Energy density, cooling, mass, and this and that. But the actual technological bits are the same. The same motors, the same power controls, the same battery technology. So you start to come to an economy where you all of a sudden can mix and match propulsion bricks. How cool is that? And these aircraft flew amidst COVID in 2000 and 2021. Hybrid Pantera demonstrator and the HY4 now operated with liquid hydrogen storage courtesy of H2Fly. But this was done in the early 2020s. And many of these components will continue their life and development towards productualization. We spoke about batteries. So here, for the first time, we had liquid-cooled batteries. And for those who were paying attention to what type of liquid this was, you may have been surprised. Pantera actually circulated fuel through the batteries to keep them cool. It turns out that fuel is actually quite a good thermal pickup medium. So imagine the safety case there and all that we had to do to ensure that this situation stood the proof of time, as well as the certification requirement for test beds. From Mahepa, we continued into a more theoretical project again, called Unifier, 2 universities and us. Again, a competition-like project. But this time, for the first time, we started to ask ourselves with all seriousness whether there is a possibility to fly people and cargo without emissions. What is the market, where you could do that, and beyond all, because look, we are an aviation company, we are an aviation manufacturer. We ask ourselves, what should the machine look like so that you bring goodness to this market? And Unifier 19 started as an exploratory research, more academic than business-wise, where every and all, at that time, conceivable powertrain architecture and aircraft architecture was taken into account and mixed up with all combinatorics and compared. In the old times, these were called trade studies. Today, people would call it AI. These knowledge elements and smash them together. And what emerged were actually a few very interesting things, including that it is not very practical to make or go make hydrogen-powered aircraft using fuel cells that are small. But as they become bigger, this actually becomes much more sensible. We also took a look at the market. It turns out, and that was quite a big revelation back then, still is today, and I checked yesterday, and the numbers are still very similar. It turns out that 95% of people who travel by air in Europe move through 69 large airports. Today this number is 71, but it's not largely different. What's reality is that there is approximately 3,000 other airports with good hard asphalt runways, between 800 and 1,000 meters long, that could well be activated for air travel because they lie in proximity where people live and where they actually want to travel to. It turns out that people don't hate air travel. It turns out people hate going to and from the airport and waiting at the airport. You know, the famous case of an 18 euro sandwich at Frankfurt International. I don't know what it costs here. That's what we did. So we started contemplating what aircraft could look like. And this was the knowledge from 2019, MAHEPA era, applied to the vision of a 20-seat zero-emission plane. So this plane has 6 engines and 4 propellers. Now, how is that? 2 engines together power these bigger propellers on the inboard side, and the same propellers and engines that you saw on HY4 or Pantera proof of concept were actually installed on the wing. And we thought we've got it. We actually embarked on a journey with universities, some institutes, and industrial design studios to paint a picture of what flying from such small airports could look like. And the first time, the vision of blue pills representing liquid hydrogen somehow emerged. So that was us, sorry. Now everybody paints hydrogen, liquid hydrogen story with these blue Viagra-like pills. So again, we are sorry. But that's what people thought of hydrogen and how it was back then. And that was the vision. Walk straight from a mini terminal to your mini plane, and off you go. Simple, right? We had MAHEPA, we had the engines. It was just a matter of doing it. Well, turns out we were wrong. So the knowledge which culminated about the powertrain architectures, how the aircraft are conceived, well, it turns out still today, there is no textbook that teaches you how to make a great zero-emission aircraft. None. Aircraft design practices in the academic domain for zero-emission aircraft sadly do not exist yet. So we are open sourcing this. We have been open sourcing all of the Unifier 19 knowledge since 2022. It's out there on the website. Use it. This is the knowledge that tells you how to go about propulsion integration and other things, and aircraft sizing included. Long story short, we now have a routine, a piece of software, if you wish. It's almost magic, that shows you the vision of the aircraft like this, with actual images, not just a collection of parameters. 5 years ago, if you asked a conceptual designer, how does my 20-seat zero-emission commuter aeroplane looks like, they would say, it has a wingspan of 22.6 meters, it weighs 8,542 kilos, and again, what does it look like? And nobody was able to say. So we actually are able to visualize these concepts, and I decided to paint a few of them. This was publicly shown before, but just as a courtesy to you all. So this routine is able to prioritize certain things, and on the upper left side, we prioritize energy spent in cruise flight, right? Be very efficient. So you'll see that what you get is essentially a flying submarine, a fish-like design. No distributed electric propulsion, very efficient tail thruster integration. And on the upper right-hand side, we say, well, but our runway is very short. So the wing grows and propellers appear. And then we start adding other things, such as the importance of noise, which is also considered in this routine. And you get towards more and more practical configurations. The winning design with the knowledge of year 2022 looked like this. Let me disappoint you, the winning design of 2024 looks different again. But what I'm trying to show you is that it is important to start early, to try and to amass knowledge, because that's how you get towards better solutions when time is right or when you need to have it. So this is the Unifier 19 aeroplane. A simulator of it is public and free. You can go and have fun. And you can fly a distributed propulsion airplane of the future. Now, Unifier 19 is part of the answer why we are doing electric flight still, why we began, why we continue to do it. It's to cater different options on how people fly. This was an example of flying from small airports to larger ones, so just between small airports for convenience, lack of noise, while being zero emission. It turns out that cargo moving is also a big need when it comes to modern lifestyle. And it turns out that cargo likes to move in much more remote places, or further away from urban centers than people think, and it likes to move during crazy hours of the night. So those who pay attention on when your Amazon box is coming, you'll see that many tracking timestamps are like 1 a.m., 3 a.m., something like this, right? It turns out people like to sleep then, and this includes pilots. So if we are to revolutionize how the cargo moving segment looks like, we probably need to remove pilots from the loop, and we need a machine that's quiet and obviously does not add to the environmental burden. Born is the Nuva V300, which is a large cargo drone. When I say large, it's very large. The wingspan pretty much matches Cessna Caravan, as does the internal volume. So the fuselage of the aircraft holds 3 regular cargo pallets. So basically, this is your flying van type of a capacity, multiple hundreds of kilograms. And this was born using the same kind of the powertrain that the Velis Electro uses, just 8 of them. Simple, right? It's all simple, but the combinatorics are definitely there. And this is also an opportunity for a quicker, more elegant certification path, because you are using previously proven building blocks, not just previously proven ideas. So Nuva is architected as a full fly-by-wire airplane. It doesn't even have a pilot seat, so it will be automatic from the get-go and later become autonomous. This is why we also started catering to autonomous flight back in 2014. I didn't speak about it. And we are more than ever engaged with the European regulators about single pilot operations and no pilot operations, as well as sensors and everything that comes along to enable unmanned flight. Unmanned flight enablement is far more straightforward and easier on electrically propelled aircraft because they are digitalized or digital by control to begin with. So they're more like a flying laptop than an aircraft that was refitted with an electric propulsion system. So this is an aircraft that is coming together as we speak, and we look forward towards flying it in the second part of this year. So how does this all assemble? We hope we are able to influence the next generation of aviators with what we do today. It starts with pilot training. I hope that we have infected enough student pilots that start flying electrically to never look back. In 2019, as a matter of fact, there were still more astronauts than people who flew an electric airplane. 583 was the number where there started to be more electric aircraft pilots and flyers than astronauts. That's how exotic electric flight actually was before 2019. Today, we enjoy a crowd of more than 5,000 people who are rated on this aircraft. So we are literally plowing the field, if you wish. Pantera is coming next with hybrid options, Nuva for moving cargo in an autonomous way, and the urban air taxi project, which is unfolding in our parent company, completes this journey of teaching, transporting, moving cargo and moving people in an environmentally friendly way with brand new products, all within 1 decade. So see you in a few years or at our booth. Thank you for any question that you might have.
Tine, this was absolutely incredible. Thank you so much. I think there's a bunch of questions in the audience here, and I need your help. First, we need 4 chairs on the stage, 4 chairs for the next panel, for John, for Jan, and for Tine and myself. And while you, please, could help me with 4 chairs here, delegating is very easy. And is there any question to Tine yet? And yeah, lots of hands going up. So first of all, Tine, you just passed the number of astronauts in electric aircrafts. I had a recent conversation with the Swiss Air Force. We have still less electric pilots than F-18 fighter pilots in the world. So still little group of pilots, more fighter pilots in the world than electric pilots. So change that. So the first question is from where? From you. Please introduce yourself with name and company, whatever, and then a question ends with a question mark.
Hi, yes, I'm Giel. I'm from Energy to Fly in the Netherlands. I've been flying the VLIS for 3 years now, so one of the first maybe. I've been enjoying it so far, so thank you for that. My question is, you touched upon it a bit, but what do you see as the biggest hurdle to place batteries in the wings of aircraft? Because I've seen in the pictures you showed, well, almost none of them are placed in the wing.
Yeah, so we have to realize that there are very, very few electric aircraft out there, and even fewer ones in regular operation, that were born as electric aircraft. So VLIS Electro was born with the electrification in mind, but the level of knowledge was 2014-15, right? And at that time, the anticipated longevity of the battery in terms of cycle life, or let's say time between major maintenance intervals, was about 100 hours. So we knew that the battery would have to be looked at quite frequently. So we decided to place it in the fuselage because it's just more accessible and less scary to open and inspect than something in the wing. Now, even today, right, these time intervals are approaching 2,000 hours, so a factor of 20 apart. And in the next generation, this will continue to climb 25, 30, 3,000 hours, etc. So this gives a direct opportunity, right, to tuck the battery into, let's say, a place where it's better integrated, but less accessible at the same time. And when we discussed structural batteries, right, there, essentially we depart from the notion of carrying the battery like a suitcase. So those who know the VLIS Electro, the battery is packed into a box, and this box is installed into the aircraft. So the aircraft carries the box, and the box carries the battery cells. Doesn't sound too clever, but that's how we know to do it today. As we continue to depart from this idea, hopefully we get rid of the box, right? And the airframe itself becomes a packaging vessel or medium for the active battery mass itself. To do that, yes, there's safety considerations to be made, but there's very real maintenance implications as well, right? People just don't want to touch primary structure very often. So it appears that 6,000 to 8,000 operational hours is about the time when people are okay with looking into the structure in more detail, because they would do it anyhow. If you look at the regional aviation, passenger jetliners, this is the equivalent of a C-check, right? Every 3, 4, 5 years. And this is basically what needs to happen so that we start getting rid of the box. Otherwise, you literally have to unpeel your airplane to inspect or refurbish the battery, which is not exactly what the aviation industry wants to be doing, right? I mean, we're just not comfortable saying, unpeel your wing to replace your battery. We're not there yet.
Okay, so 2 more questions, and then we open the panel, which is a conversation as well, and based on questions on the audience as well, but then we have a greater speaker panel.
Thank you. My name is Gerd Hinzenkamp from APL Landau. So as long-term developer of both fuel cell systems and batteries, first of all, congratulations on your really inspiring presentation. One remark from the view of our automobile industry, of course, there we have the same tendency, cell to pack, cell to car. So no longer battery cases in the usual way, but the same tendency that you just showed up. My question would be, how do you see in the future the sweet spot between battery electric aircraft and fuel cell driven aircraft in terms of endurance, in terms of weight, maybe, or passenger?
Yeah, so crystal balling the future is tough. So from today's perspective, it doesn't seem to make much sense to conceive large battery-only powered aircraft. And when I say large, 7, 8 seats is probably the tipping point. There is also quite a visible threshold when it comes to airspeed or range, where batteries definitely start needing help. And when I say start needing help, I mean not the aircraft size or look or feel, right, or would it fly, but what would emerge is an aircraft that is not practical, too big, too heavy, but you also need to consider where do you recharge it and how the energy for recharging actually gets there. Once you venture into megawatt level charging requirements, this basically means that you are switching on and off a very large shopping center. A very large shopping center is about 1 megawatt. An Aldi or a Lidl is about 300 kilowatt, just for some perspective, right? For each aircraft that comes and goes, an electrical grid company don't like that. So we either have to be much more serious about local presence of energy, battery banks, right? Buffer batteries. Second use of batteries might enable that. But what's better in terms of circular economy, just because it's more practical for many other things, is actually local generation of hydrogen. And the idea of airports becoming energy hubs. So the gentleman from the Netherlands might know the airport of, I hope I pronounce it properly, Groningen. Groningen. Help me.
Groningen, they have hydrogen-powered APUs.
So they are the largest single power station in the Netherlands. 20 megawatts from solar alone. And they call themselves an airport. So this, I think, is a lesson for everyone. We can start thinking about how to further employ airports, smaller ones too, so they become energy hubs and they actually do something interesting for the communities, and the communities wouldn't be interested in bulldozing them, but actually keeping them there so that we can enjoy them for flying, for transportation, and making them into energy hubs. Right? And fuel cells, I like them, just like Jean does, also because they offer reversible power flows. You can use them to create electricity from hydrogen, but you can also use them in reverse, right, to create hydrogen from electricity. So it becomes quite an interesting notion when you consider that.
Yeah.
And batteries are just mechanical. You know? Batteries are bricks. They are not very flexible when you want to convince them to start life in one type of a vehicle and continue life in the next, right? Where hydrogen is much more elastic.
One more question, and then we open the panel.
Here. Yeah, my name is Blake Moffett. I'm from Sikorsky Aircraft in the United States in Connecticut. So my question was dealing with you've had to work with the regulation authorities a lot, and you're working with type certification with essentially new technology that I assume they probably don't have people familiar with, so can you talk about what are some of the challenges that you guys have run into and that you see in the future for actually getting the certifications that you want on your products? And relating to like electric propulsion systems and fuel cell propulsion systems as well.
Yeah, so one cannot expect that an aviation authority is equipped with the same level of knowledge as you are, who's researching and pushing the frontiers of technologies. But you'd be surprised how willing the authorities are actually to listen and learn. And we had wonderful cases nationally. France and Switzerland were countries where pre-series of aircraft that became the Veris Electro were actually flying under exemptions with regular flight schools and regular people. EASA included is staffing themselves up with more and more experts from non-aviation domains, power electrics, railway, maritime, which all have to do with moving electrons or thin gas or utilizing more software-defined systems. I think the element of whether you will be received, let's say, well or not that well, is how believable your project seems. I think walking before running makes a lot of sense. And if you come up with something that sounds more like a dream, although you internally might believe it's total reality, the acceptance factor or let's say the acceptance obstacle becomes very real. So dissecting a long journey to small chunks helps. And this is basically our journey, right? It's a journey of a very measured approach, going from small aircraft to larger, starting with a simple battery power controller motor and then elaborating on the architecture as well as the aircraft. But it's a continuous journey of education that's actually bi-directional. It turns out aviation authorities also know a thing or two, in particular when it comes to operating your new machine, however novel that is, right? So the type certification as an example of an aircraft is only a piece of the puzzle. Training syllabus, how does that look like? How do people transition from a regular plane to this? How do we keep them safe? How do we handle the maintenance side of things? Education.